IES's Startup initiative. So let me talk to you about the IES's Startup Mitra. So this is one of the initiatives started in the year 2022 just to promote the startups in semiconductor industry. So as you all are aware that IESA is basically Electronic Semiconductor Association, and we actually deal with the members of semiconductor industry, and we have around one more than 100 plus startups in this domain. So we wanted to cater their needs and help them in every aspect. So that's where like the Startup Mitra initiative came up, and we have almost helped the startups to avail the incentives in the state governments and even the central schemes as well. So as one of that thing, like we are trying to get the speakers or the experts from the different domains, which can help every one of you to get at least the basics of it or some knowledge what is happening in semiconductor, and what are the trends that are coming up in the semiconductor industry, right? So today's topic is all about like the introduction of MATLAB for semiconductor manufacturing. So to talk about this, we have a speaker from MathWorks. So today the speaker is going to cover about the overview of MATLAB's role in semiconductor manufacturing within Industry 4.0 framework, data analysis, visualization, and IoT integration, smart manufacturing and process simulation, case studies, AI applications. So I welcome today's speaker, Mr. Jayant Balaji from MathWorks. Let me give a brief introduction about him. Jayant works as a senior application engineer at MathWorks in the area of intelligence. He primarily focuses on areas on data analytics for the application involving time series data. Jayant has around 10 years plus years of experience in research and industrial, where he was working as a developing AI, ML, DL solutions for various application areas such as retail optimization, computer vision, and natural language processing. So prior joining to the MathWorks, he was working as a senior AI engineer at Impact Analytics. Thank you so much, Jayant, for joining. And today, I am sure, like all our audience would get at least what is the MATLAB in semiconductor manufacturing. So over to you. And one last quick thing, like we'll take up a Q&A in the last 15 minutes. So whoever is having the questions, please feel free to post the questions in the chat box. And I request everyone to mute yourselves so it'll go like in a smoother way. Thank you so much. Over to you, Jayant.
Thanks, Gautami. And hi, everyone. It's a pleasure to meet you all. Yes, today we thought of discussing with you related to the workflows that how MATLAB can able to help you in the overall semiconductor manufacturing industry segments. And there is a motivation for us to decide on this particular topic. Like we hear a lot of startups working around this particular area, like Industrial 4.0 for semiconductor manufacturing and things like that. So that is one of the motivation for us. We thought of discussing how MathWorks as a company is also supporting the this particular journey or particular big trend towards Industry 4.0 and things like that. With few case studies or few directions that we are seeing from the field, especially from the semiconductor manufacturing side, what we are hearing from the field and how it's getting direction and shape towards the betterment of the overall process and things like that. So that's the high level agenda we have for today. And as Gautami mentioned, myself, I'm Jayant. Along with me, I also have Prashant in the call, who'll be helping me with the creating the questions and sending it to me towards the end to discuss in detail about that. So without further ado, let's quickly get started. India is rich in the manufacturing, but with the recent transition that we are seeing towards big push in the manufacturing segments, we are seeing a lot of things that is moving towards cost reductions, improving the time to market or the quality improvement and things like that. So that is one of the things that we are also seeing in the semiconductor manufacturing side. It is not different from any other manufacturing industry segment. Only thing is that it has its own niche areas which it want to focus in a way that it reduces the cost and also the improve the time to market and also kind of a quality improvement and things like that. So in a nutshell, if you look into this big trend of manufacturing, it's also like we are often hearing for past 1 decade about Industry 4.0 and things like that. It is not other than improving the existing workflows and in a way we want to enhance the quality of the products that we produce and also optimize the resources that we are trying to get into the workflows. So that's where in semiconductor industry also we have a lot of APCs or advanced process controls. We hear a lot from our end users. Similarly, predictive maintenance kind of workflows And this is the one industry which generates a lot of data when compared to other traditional industries. For example, we are working with one of the paper polishing workflows where we happen to know that each and every iteration of polishing it generates more than like several terabytes of data, which means there is so much of information that is being generated from this semiconductor manufacturing industry segments. So, which in a way it is good, like that provides us an opportunity to improve the existing process and also like improve the quality of the products that produced and also like accelerate the overall time to market. So that's where also we are fitting the same Industry 4.0 framework to the semiconductor manufacturing kind of industries. So how we designed our today's session is we thought of like having several case studies that we happen to encounter in past few years within MathWorks, and also like what how they solve the challenging problem. In a way, like when we say solve the challenging problem, there is no monopoly or there is no single player can solve a complete problem. There should be a synergy between the manufacturer, wafer producer, as well as the solution provider or a system integrator, and so on and so forth. So that's where like there should be a cross section among multiple industry segments to achieve this journey. And what we plan to show you is we thought of taking you through several case studies that we encounter in the field and what end of the day what they are trying to solve. Namely, it can be like parameter optimization or predictive maintenance, or it can be like robotics, visual inspections, and so on and so forth. So that is one of the things that we thought of showing it to you today. So when it comes to the Industry 4.0, like as I mentioned, we are talking this for quite some time. Like in late 2000, like 2010 onwards, we are hearing this trend of Industry 4.0 or 4.01, and so on and so forth. Like industrial IoT or several different terminologies like smart factories, connected factories, and so on and so forth. But if you ask me from my personal experience, like whether we have achieved the full potential of Industry 4.0, the answer is no, because there is a lot of things it is need to be retrospectively fitter, and we need to improve the overall workflows and things like that. And the newer generation machineries are extremely coming into play to address these kind of industry IoT challenges. But when you take it in a nutshell, like this is a report from McKinsey. When we have a quick look at it, there are several challenges that is need to be addressed before achieving this Industry 4.0. Namely, it can be like it can be like a maintenance cycle is increasing by multifolds, how to optimize that, or how to predict that a priori, or how to have a digital performance management system so that I can able to monitor the connected machineries that is used for this kind of manufacturing process. And also like how to like enable the like kind of asset optimization, which is one of the crucial step, because like we have multiple machineries that is being connected to achieve this overall process. So that's where like if there is any provision to optimize the resources, it can be as simple as like reduction in 2% or 3% in the overall power consumption, and so on and so forth. So there are multiple challenging problems that has been associated with this industry segments, and that is also one of the opportunity for startups like where we see a lot of solution providers are coming in the space. Probably like it can be predictive maintenance, or it can be like kind of a visual inspection kind of a workflows, or it can be like optimizing the existing assets and things like that. This is a common trend that we are seeing, where there is a lot of potential for the startups who to get into these kind of areas, and we are seeing the same trend from our interactions with the multiple users, and it's being like doubling, or like it is kind of like growing every year. So I've been working with Matrix for almost 5 years now. Like from day one onwards, we are seeing this trend, and it's been more than multi-folds. It increased these kind of solution providers, especially in the kind of manufacturing segments. And it's nowhere different with the semiconductor manufacturing, because it poses the equal challenges and equal opportunity as well. So that's where like we thought of discussing the finer granular details, like where and all like we are seeing this kind of trends and things like that. Maybe let's get into a little more deeper in things of like several manufacturing trends, especially in the like kind of semiconductor manufacturing. One of the biggest thing that we are seeing is supply chain management. Primarily, like we have semiconductor device manufacturer who manufacture devices such as like ASML and so on and so forth. On the other hand of side, there is a consumer of these machineries who manufacture semicon chips. So that is one of the things that where there should be a synergy between these two users or these two consumers, we would say, to produce an optimal design for their equipment such a way that overall efficiency is improved. So instead of just bringing a case study that we thought of like trying to solve or what like ASML and SK Hinks, they try to work together, like we thought of just showing it to you. But eventually, like if you take a larger picture, what they did is, what we are trying to solve is, MATLAB can be used complete throughout the supply chain. It can be starting from the device manufacturer all the way to the consumers. So in this case, like ASML has applied a model-based design to their lithography equipments. Primarily, if you want to know more about what you I mean by model-based design, it's one of the way like you can able to devise your equipments in a much more elegant way and in a way that you can reduce your efforts in like finding validation and things like that. So all those things in a synchronized fashion, you can able to start developing your machineries. And same way, like 3T mentioned over here, like they also applied model-based design, including the HDL workflows to develop an emergency braking system for their wafer handling robots in the semiconductor manufacturing side. So that's how like they started integrating the machineries and things like that. For example, one there is a semiconductor like wafer manufacturer on another side, or lithography machines on the one side. The other side, they started using that where there is one more component coming into play, how to pick and place those manufactured wafers and things like that. And finally, like SK Hynix, it's nothing but a semiconductor manufacturer uses MATLAB for various simulation process and data pre-processing workflows and things like that. So in a nutshell, when you take about the overall supply chain management that is shown here, starting from the device manufacturer all the way to integrator who integrates the system along with the requirement of the semiconductor wafers and the semiconductor equipment, semiconductor manufacturers. So all these people came into a common platform or common board to understand their requirement and process the workflows in a simulated or a simplified manner. Maybe we can get into the details of one of the use cases which both ASML and SK Hynix work together. Um, in this case, like like just to give an idea, like overlay errors is one of the critical factors when it comes to like meteorology or lithography kind of equipment, right? So when there is higher overlay error, there is like high chance of like yields reduction in yields. Therefore, it is effective to use a optimal methodology for virtual meteorology that estimates the variables and things like that in appropriate way, so that the overall yield can be improved, right? So in this case, it's an exact interesting use case where both machine learning is used as a tool to solve this kind of meteorology workflows, and also like both the equipment manufacturer as well as the consumer who consume these equipments come into common ground to understand how it can be utilized for the betterment of both the sides. In a way, they try to reduce the challenges that is posed by the supply chain workflows. For example, if there is a high meteorology or like high error in the overlay errors, which means it reduces the yield, which affects the overall supply chain or revenue streams and things like that. Whereas this is one of the requirement by the semiconductor manufacturer, so the device provider also they can able to understand and add those kind of features to their product such a way that it matches with their requirement of their consumers. So here, in this case, they found a common ground or common language to use MATLAB because like both ASML and SK Hynix, they started developing this workflow. And interesting factor is both of them, need not to be, they were not a machine learning expert. Ideally, they started using the no code, low code workflows, and they could able to quickly get started or develop this end-to-end systems, which could able to perform which can able to detect the overlay errors in the meteorology or like overlay errors in the wafers and things like that. Right. So that is one of the interesting use case where if you're starting new for any of these kind of workflows, most of the time, what people have a habit is go and start coding or developing the algorithms, those kind of workflows. But there are like so many numbers of tools that is available in market, which allows you to do the things in a much more simpler way or easier fashion. The problem statement is the thing that should come from you. The rest of the things can be offloaded or automated to the tools. So here is a best example from ASML where they are a process engineer and they are not a data science expert, but the requirement is to find a way to reduce the or to find a way to detect the like kind of overlay errors. And the solution they look forward is using machine learning, but they are not a machine learning expert. What they eventually do is they have uploaded their explorations of software development or the machine development with help of tools. And in this case, it is MATLAB, and they could able to develop a machine learning based like kind of a workflows, which improves the overall process. All right. So in a way, like it's a straightforward one. It's also the trend that we are seeing in the industry. Like if you want to solve a problem statement, just focus on the problem statement, stick it to your domain, and how to solve the problem statement can be offloaded to several tools that is available in the market, and you can able to reduce your overall time that is taken to generate or develop these kind of workflows, right? So this is one of the case studies where MATLAB is heavily used in kind of machine learning based workflows and things like that. And it's also one of the requirement of process improvement side from the like kind of semiconductor manufacturing segments. So let's also quickly get into the other common trends that we are hearing. For example, predictive maintenance, visual inspection, imaging kind of a things. This is a common trend that we are hearing because you're working on highly critical equipments. The downtime, the unprecedented or unpredicted downtime will happen to affect the overall process itself, and it can cost you $1 million or more than that. So that's the reason, like you want to, for many of the people are trying to forecast their maintenance cycle what, from the data that is being generated from these kind of highly critical equipments, especially in the case of semiconductor wafer manufacturing or semiconductor manufacturing segments. Each and every minutes or each and every seconds counts, and the unprecedented downtime may lead to loss in several $1 million and so on and so forth. That's why predictive maintenance is one of the interesting area that we are seeing, where several industries are trying to understand the data that is being generated from their machineries to devise a strategy in such a way that they could able to predict the maintenance cycle of their equipments. So why it is necessary? So if they know the maintenance cycle, they can perform the several planning accordingly, and they could able to reduce the downtime or unpredicted downtime, which means they don't want to have any accidental downtime because of the equipment failure. If the equipment is failing because of the accidental failure, which means you are losing a lot of hours, which in a turn you are losing a lot of monies. That's the reason, like forecasting the anomalies or condition monitoring or remaining useful life estimation kind of a workflows. We are often hearing one of the common trend that is coming from the semiconductor manufacturing side of it. So other side of it, like a kind of a visual inspection where they want to use some camera based or spectrograms or kind of a microscope kind of images to understand the quality of those kind of manufactured devices, manufactured wafers, and so on and so forth. That is one of the common other trend that we are seeing, especially in India, especially the solution providers like startups who are working on these kind of areas in collaboration with the semiconductor companies. We are seeing this trend quite common. And each and every workflows, like starting from predictive maintenance, visual inspection, sensing and imaging kind of things, has its own challenges. But one common thread is now we are in the world of AI, where AI is dominating a lot of things. Of course, it's a both in a way it's good as well as bad. But idea is that this AI can be thought as a tool to address these kind of problem statements, where you can able to leverage the superpower of AI, and you can able to analyze the data that is being generated from these equipments to predict the maintenance cycle, or it can be visually, you can able to inspect or detect the anomalies, abnormalities, or different types of faults or defects in the manufactured goods, in a way that what we are trying to do is, one is increasing the revenue stream by reducing the downtime, and other side is we are also in the marketplace where our quality of the goods that is being manufactured is improved, right? So each and every technology like this highlighted one can be solved with AI-based workflows, but each has its own challenging problems. For example, like if you're trying to get into the like predictive maintenance kind of a things, one of the common thing is most of the time it is a time series data, right? And the other thing is like how you can able to find a suitable model, how I can able to use it to predict certain anomalies. If I devise an algorithm, how to take it to the final deployment and things like that. So end of the day, no one is just working on just a research problem just for publication kind of a work, because eventually even the research problem need to go to the production to generate the revenue streams. That's where the deployment also comes into play, where you're converting your research or converting your work into a deployable work or a product and furnished to product such that it can be utilized for certain cases. So in this case, it is a predictive maintenance. What it is mean by that is like it can be like several equipments, and you're gathering a lot of time series information from those equipments, and then you're trying to devise an algorithm such a way that it predicts the maintenance cycle. And eventually it cannot just sit on your laptop or desktop. It want to go to the production setup. That's where the deployment comes into play. So it's a common thread, but ideally, where MATLAB comes into play is it streamlines these workflows. So the majority of the challenges, like how to bring my data, how to devise my algorithm, and how to finally take it to the deployment and things like that. So that's where, uh, as I mentioned, you focus on the problem statement. In this case, it is a predictive maintenance problem statement. And eventually, how to implement or how to take it to the deployable solution, you can upload it to a tools. All right. So in this case, like you can able to leverage the data that is being generated from your equipments, devise an algorithm automatically. That's one of the things I'm just trying to stretch, because there is no straightforward approach to decide which machine learning algorithm will use for a certain type of problem statement. It's a big problem that we have when it comes to data-driven technique. That's where you cannot manually go and change the parameters or change the different architectures and try out multiple combinations in manually, because it is a boring stuff. No one wants to just tweak the parameters manually and try different trials and compare the results and things like that. So in those kind of scenarios, you can leverage the power of tools. You can simply offload the algorithm search or a pre-processing search, and then develop an algorithm which matches your suitable accuracy. And finally, you can able to directly take into the deployment phase, which means if your end device is cloud-based architecture, generally what we'll do is we'll containerize the workflow and deploy it, or build an archives and deploy it on the kind of a cloud-based infrastructure. In this case, there are a lot of manual efforts required, but that can be completely uploaded or automated, which will show an example like how you can able to do that. But end of the day, as a domain engineers like you, the one of the message that you want to try to capture from here is it can be any type of problem statement. In this case, it's a predictive maintenance problem statement. That's the thing that you're trying to do. And you are trying to understand your maintenance cycle, but how to solve that, you don't want to worry about that. There are multiple tools available in the market that can be utilized or leveraged to do your task with a much more simpler fashion, and you can able to spend or focus your efforts only on the domain related problems. So that is the thing that we are trying to showcase here. We have multiple uh, customer references in this area, especially on the predictive maintenance. We are not just showing it here due to the like NDA and copyright things that we have, but there are, if you just Google it, MathWorks plus predictive maintenance, it will pop up with a lot of predictive maintenance workflow, even in the semiconductor world, right? So maybe just shifting a gears, this is on the time series side of it. As I mentioned, these are the AI avenues, and the next AI avenue which we commonly hear is primarily on the visual inspection side of it. So we want to detect the different types of failures or different types of patterns, the things like that. And again, the challenge comes is how I can able to bring my data, how to generate my model, or finally, if I want to take it to the deployment phase, what is the latency that I want to focus on? Because here we are just scaling the problem from one dimension, like which is a time series, to the multi-dimension problem. So that's where the computational complexity is also increased. When you take into the deployment phase, the problem again, it is a multifold thing. And most of the time it can be automated, by which you can able to directly utilize the inbuilt functionalities and constructs and directly take it to the final phase of even for the deployment side of it. So again, to reiterate, in this case, you are trying to solve a vision-based problem. Even though the volume of data or the computation wise, we are scaling up to a larger extent, but eventually the challenge remains same, how to develop, test, and deploy it. So all those things can be streamlined and you can able to achieve a better results and things like that, right? So these are the common AI trends. Just to recall, we just start off giving you an idea about one of the trend what we are seeing on the AI is kind of predictive maintenance for manufacturing devices. Another is like visual inspection kind of a things for quality improvement of the furnished goods and things like that. These are the common trend that we are seeing it from the field, especially on the semiconductor manufacturing side. So on the other hand, just taking a shifting towards it, now we developed an algorithm, as we mentioned, like it can be on predictive maintenance or it can be on like a visual inspection and so on and so forth. The interesting question comes, how I can able to operationalize the algorithm, which means I developed an algorithm. Now I want to take it to the deployment phase where I want to connect with multiple real world system in the field that I'm encountering. How can I able to connect that? And how can I able to bring those data into the deployed algorithm, how to generate a meaningful insights for those kind of algorithms. So that is one of the reason, like you can also think MATLAB as an integration platform. The interesting factor is you can able to connect the different data sources easily on the deployed algorithms, as well as you can able to have multiple inference points. It can be a dashboard, it can be visualization, or it can be report generation, or it can be simple controls and things like that. But end of the day, the analytics portion that is sitting in between acts as a gelling feature between your data that is being generated from your machineries as well as the visualization or inference that you're capturing to get from the devices. In this case, we are using a product called MATLAB Production Server, which hosts MATLAB-based analytics algorithm and can able to connect with different streaming infrastructure ranging from the data all the way to getting the business intelligence from those data and things like that. So that is one of the USP as well. Like you don't want to manually code or rewrite anything. Ideally, like it can be auto translated with the tools, and you can able to seamlessly deploy, integrate, and attach it with your existing system. And even this also it's kind of a no code management platform that has been also shipped, which means you don't want to worry about how I can able to scale or do the job scheduling to my algorithms and things like that. End of the day, it's all operational problems or an IT problem, which is completely offloaded to the tools, and you can able to seamlessly take it and deploy it. So it's not alone works for AI, but it can also works for any kind of IoT platforms. Maybe if you get into the details of it, for example, advanced process control, where we try to control the parameters of the overall manufacturing things to optimize certain workflows and things like that. So that's where it can be a AI problem or it can be a non-AI problem. But eventually, like you can able to achieve the similar kind of integration work for the algorithm that you develop and capture and deploy it on your end field. So in this case, we are just showing how we can able to take it and deploy it and things like that. And moreover, one of the point which we want to reiterate here, we are just showing a cream of workflow or the trends that we are seeing. We are not showing the finer details. And we can also have a dedicated discussion to understand the finer details. But ideally, here we are showing the trends that what we are seeing from the field and how what are the different avenues that we are happen to work with different users and things like that. Right. And just shifting a gear towards like operation optimization, which is nothing but advanced process control and things like that. So eventually, what you're seeing here is like you have a complete plant model of your manufacturing site has been replicated as a simulation model. So whatever you're seeing in the center figure, it's nothing but a simulation model that has been developed for your overall process itself. It's not just alone component and things like that. It's a complete full-fledged system that is being replicated as a simulation model. You can even call that as a digital twin, provided that you have a feedback with your existing asset to the system. But eventually, why this kind of models is necessary or how it is going to benefit you is you can able to you leverage the simulation model to fine tune or perform what if analysis. For example, all the worst case analysis you can able to do it because it is a simulation model. There is nothing catastrophic failure you can able to see with the simulation models. Ideally, you do all the foolproof kind of things where you do all the forceful scenario testing and all those things in the simulation model to understand how your model behaves in your actual systems, and then you can able to perform appropriate set points. Why we are performing the appropriate set points is to improve the yield or optimize the resources that we are happen to encounter. Even 2% improvement in the power efficiency is a big number that we are seeing from these kind of process industries and things like that. We cannot directly go and implement our logic directly on the field because it is going to be highly catastrophic. That's the reason before even taking into the field, you can able to bring it in the platforms. In this case, it is Simulink, and you can able to perform like kind of what if analysis, understanding the set points and things like that. And then finally, you find the best heuristics and take it and deploy it onto your field to get the actual information and things like that. So that is also one of the area that we are seeing where MATLAB comes into play, where it performs the process optimizations or operation optimization and things like that. So that is one of the areas that we are seeing a lot of trends that has been happening. We improve the efficiency of like products or the power supplies or those things that is being utilized. And the other things what we are seeing is like monitoring the like operators, like whether they are following the safety standards, right? Those kind of things. It's also one of the surveillance kind of application that we are seeing where the camera-based solution is utilized to perform the complete complete movement tracking of operators, whether they are following the kind of adhering to the standards and so on and so forth. So that is also the common area that we are seeing from the field, which is also one of the avenue where we are seeing a lot of startups are working towards this kind of a surveillance-based application. And again, there are a lot of simple app-driven implementations are available in MATLAB by which you can able to use that and implement the surveillance application. In this case, we are just showing an operator movement monitoring and things like that. But eventually, even you can able to focus on the conveyor belt operations, the furnished goods, how it is going, and things like that, and so on and so forth. So maybe just to recall, like what we started with this like kind of overall big trends in like kind of a manufacturing. So we showed several case studies or several use cases that we are seeing from the field, maybe starting from the supply chain where device manufacturer and the wafer semiconductor manufacturer, how they collaboratively worked and devised workflows and things like that. On the other hand, if you're working on predictive maintenance kind of things, we showed an example how you can able to build your own predictive maintenance algorithms and streamline the things. And if you're working on IoT kind of things, how MATLAB can help you to work as a integration platforms to gel the different kind of infrastructure and get the insights out. And even kind of a visual inspection or a kind of like surveillance kind of application or advanced process control and things like that. We have shown a trend that we are seeing from the field. And now maybe the question that comes into your mind is like why we are talking about that, because Matrix, if you take, it's a software company, and it's been primarily used in automotive and automotive and aerospace. If you ask us why Matrix is talking about this particular manufacturing segments, because our biggest third industry segment is manufacturing or industrial automation, where whatever the case studies or snippets whatever we are showing, it is an area where Matrix is heavily involved with the development, as well as from the domain engineers like you, we got the insights and things like that. And primarily, like we gel the architecture together to form the overall solutions in a much more simpler and easier manner. Maybe to get into the one of the thing is like how we are supporting these kind of workflows. The thing is, it ranges with multiple flexible features that is available in MATLAB. Just to give an idea, if you're working on images, we have a dedicated stack that solves your image-based workflows. If you're working on time series kind of application, there is a dedicated stack which takes care of time series kind of applications. And we primarily focus on the engineering applications. So what are the engineering applications that we try to show? It's kind of predictive maintenance, signal processing, image processing, those kind of things. And it's a tool developed for engineers, and you can able to easily use and leverage those workflows for trying to solve any kind of workflows. In this case, we are showing the manufacturing kind of applications. And one of the interesting factor is it's kind of a no code, low code workflow that we support, which means it's not necessary for you to know MATLAB, or you don't want to be a programmer to solve a problem statement. So all the problem statement that we showed earlier are ranging from the supply chain management or like kind of machine learning based predictive maintenance or visual inspection and things like that. So they have spent very less amount of time in developing these architectures, which means ideally they focused on the problem statement, and the implementation point of view or algorithm development point of view, it has been completely uploaded to the tools primarily used in this case. It is a MATLAB and its toolboxes to accelerate your overall workflows. Not alone that, whatever you develop in MATLAB or Simulink or its toolboxes, ideally, no one wants just to be worked on as a research problem statement sitting on the laptop or desktop. It can be easily taken and operationalized, which means you can take it to the different deployment strategies. It can be cloud, or it can be kind of embedded systems, and so on and so forth. So one of the interesting startup that we happen to work just few months before is they came to us. They want to understand how they can able to take this predictive maintenance algorithms, especially for the semiconductor manufacturing equipments, and convert that product into a software as a service kind of things, which means they want to have a subscription model for their softwares, especially on the predictive maintenance and things like that. That's where there are multiple tools available in MATLAB to do those kind of workflows, and you can able to seamlessly complete your task. Task is predictive maintenance, and the workflow they want to choose is how to have a like software as a service kind of subscription model, and then we have supported them, and it can be taken and taken to the final deployment and things like that. So that's the high level work we thought of showing it to you. Apart from that, this is a common industry trend that we are also seeing in India, where multiple startups are coming in this space, especially as a solution provider or system integrator, to provide a software-based workflows targeting the semiconductor industry segments. So that's also one of the area that we are also heavily investing. Even our investment strategies are towards that, and we will be happy to discuss with you in detail. And this is the high level thing that we want to discuss it today, and we can have a question and answer session now. Probably like Prashant, if you happen to see any questions that you see from the tools, let us know. Um, Prashant, do you find any questions from the chat? And I couldn't able to see that.
I think there are a couple of questions which I
Okay.
can see, Jayant.
Okay,
So
sure. Let me.
one second, let me read that out for you.
Okay.
So first one is like, please also let us know how new startups have opportunity in this value chain with minimal investment.
Yeah. So this is an interesting question. Like primarily on the investment side of it, we have seen startups are not investing a big on this money because at the end of the day they are working on the software development side of it. That's where one of the thing which we want to talk also give a high level idea about tools offering, which means if you are part of an accelerator, Mathworks has tie up with multiple accelerators across the board where you can able to access the complementary licenses, which means the development cost is absolutely zero for a software development. So, and you can able to develop the software for like you can use the software for almost 11 months or 12 months for free, and you can able to complete the overall solution software that you're planning to do. And when it comes to supply chain or like kind of a different products that we showed, ideally like it is focused on the algorithm development and taking it to the deployment. So that's where majority of the effort is going on. And when you say algorithm deployment for the proof of concept or the MVP kind of a workflows, people are using these kind of complementary softwares that we offer, and they complete their MVP to get the funding or proposal or the new kind of a projects and things like that. And in a nutshell, I would say like it's a minimalistic effort, both in terms of money as well as like kind of a man hours, because all these things are no code, low code workflow, which means with minimal programming language, only focusing on your domain, you can able to achieve a certain amount of tasks that you're focusing on and complete your MVP or a product even. Right. Uh, Maybe.
Okay, there are couple of more questions.
Yeah.
Um, okay, they are asking like about sharing the presentation and let us know various tools which can be used at a different stage of silicon wafer to chip. So the presentation would be shared in our on our YouTube channel, so you can just see the recording, and maybe you can answer this
Yeah. Yeah.
various tools which can be used at different stage of silicon wafer to chip.
Exactly. So ideally, like just to clarify, we are not a EDA tool vendor or a EDA. Our tools are not directly as a EDA tool like Synopsys or Cadence, where you develop the complete level of architectures and things like that. So ideally, but we coexist or collaborate with Synopsys and Cadence tools. Where it comes into play is you can able to develop architecture in MATLAB, and that can integrate with your Cadence Synopsys workflows, both in terms of testing, validation, and deployment. And one interesting factor again here is you work on high level workflows. For example, you want to develop an HDL IP for a machine learning problem statement. If that is the requirement, you can able to still work on the high level workflows such as app based workflow in MATLAB, and you can able to generate HDL IPs, and post that you can able to leverage the different EDA tools or a silicon kind of a workflows where you want testing it on FPGAs or prototyping it on FPGAs or generating an ASIC workflows like gate level netlist and so on and so forth. But ideally, you can able to start focusing on the problem statement, and you can able to develop in MATLAB, and MATLAB provides you an opportunity to translate into HDL IPs. And from there onwards, you can able to integrate with several other tools where you perform place and routing or power optimization or generating the tape out and so on and so forth. But that is it's a pre-step, and it's a way where you can able to start with a minimalistic effort and the focus on the problem statement, and then get into those kind of areas. Right. I believe that also answers one of the question posed by Ninad in the subsequent things, how it is different from other EDA tools. All right. Yeah, Gautami, I can able to see the questions now. Like maybe we
Okay,
can
okay,
take
okay.
that. Yeah,
Please take it. Yeah.
yeah. So there is a question from Dr. Panduranga, like how to train a polytechnic students as human resource need of electronic industry with respect to MATLAB. Uh, so just to give an idea, like we have partnership with several institutes where they have on multiple academic institutes are using MATLAB workflows for teaching and things like that. So ideally, it's a straightforward one. We have a dedicated education team who focuses on starting from the curriculum engagement, where you can able to reach out to them, and they will be helping out to formulate the courses and syllabuses in alignment with the industry requirement, which with the help of with the flavor of MathWorks for implementation, MATLAB tools for implementation and things like that. Ideally, Dr. Panduranga, you can, if you can able to drop your mail IDs or if you can name the institute that you belong to, we will, if possible, like I may also need to check with Prashant how this works, but ideally, like if you're already part of our existing academic users, our education team will reach out to you to help you with formulating the curriculum with respect to the industry standards along with MATLAB-based things. It also includes lab exercises or syllabus formulations and helping your research scholars and things like that. And eventually we see this trend from multiple academic institutes, and you can able to replicate at your end as well. Okay. I also see the next question, like how can MATLAB be used to create and solve equations that are based on modeling of analog circuits? So MATLAB as like you can simply think MATLAB as a native programming language or a simple calculator. Ideally, like you can able to key in your equation as natural as possible, and you can able to use the inbuilt solvers or inbuilt optimization tools to try out, simulate or accelerate or develop your solving your equations and things like that. So it's a straightforward programming environment. So ideally, like you can able to use that as simple as a calculator all the way to developing your overall systems, solving very complex equations and things like that. And there is a dedicated like page which we'll be happy to share with you, like MATLAB for electronics and electrical engineers, which talks about a lot of this analog circuit implementation in MATLAB, and you can able to use or replicate at your end. The other question is from Rajat, like how do you compare with ANSYS IntelliSuite for process design? Are you now a substitute or a companion tool? Maybe I fear that I'm not a right person to answer that because I'm not familiar with the ANSYS side of it. Uh, Probably like if you want to, maybe like I can direct this question to the respective team who is familiar with the answer side of segments as well, so that they will be happy to answer your questions as well. And we are taking a note of your questions as well. We'll be happy to reach out to you. Yeah, and thanks, Prashant. Like for example, like Prashant has dropped a link to accelerator program, which means we collaborate with multiple accelerators across India. We have like several hundreds of accelerator partners with MathWorks. What does mean for you is like if you're part of the accelerator that is already enrolled in our program, which means you start any startups that is part of the accelerator can have access to the complimentary startup license, which includes all the products that to develop algorithm or deploy the algorithms and so on and so forth. And you will get a complimentary license for a year. And with kind of like 10 license numbers, you can able to use it if you're part of an accelerator, things like that. Yeah, thanks, Dr. Panduranga, like sharing this. Probably like Prashant and myself will take this up with our education team to understand whether Government Polytechnic of Belarus, Hassan is part of our academic engagements. And if answer is yes, we will definitely reach out to you. And also thanks for sharing this mail ID. If it's possible, it will be good to share your official mail ID because the Gmail ID will be blocked by us. So that's the reason we cannot directly interact with Gmail IDs.
Right.
Yeah.
So I think it was a great session, Jayant, and MATLABs, we always think we will have a different perspective, but like, what it can be done in semiconductor industries. It is a new and a fresh, concept is what I also feel, and all our participants would have got some insights about it. And then like, your presentation was also like very crisp and clear that what is necessary, like, how it can be used. So this was an insightful session, definitely. So I would thank you so much, like, once again, you and your team, Prashant also for coordinating and, for getting this and for making this happen. So we at IESA, we appreciate all your efforts and thank you so much. And we look forward for more insightful sessions in the future.
Thanks a lot, Gautami, and thanks,
Thank you.
IESA.
Thank you so much. And thank you everyone, for attending the session. And this session link or if you want a recording link, it will be put up on the IESA YouTube channel. Please just go there and then, you can share it among your network as well. Thank you so much. Thank you all.
Thanks, everyone. Thank you.